Hello my dear students and my dear friends. Today we have taken a new chapter, permutation and combination, and we shall start exercise 6.1. At first we have to know what is the literal meaning of permutation and what is the literal meaning of combination. In simple language, permutation means arrangement and combination means selection. Today we want to start exercise 6.1. Before starting this exercise 6.1, we have to know a simplest term called factorial. Okay, so what is that factorial? Suppose a number is written like this, factorial 6, or we can write like this also, 6 factorial sign. What is the meaning of factorial 6? It means 6 into 5 into 4 into 3 into 2 into 1. Means from 6 to, in the decreasing order, we shall write up to 1. Similarly, suppose factorial 4. What is the meaning of this? 4 into 3 into 2 into 1. What is factorial 10? Means 10 into, then what is the next decreasing number? 9, 8. In this way it will go on into 2 into 1 at the end. Okay. Now similarly, okay, if we want to write factorial n, we shall write like this in the decreasing order. N, what is the next number? You see, if it is 10, the next number is 10 minus 1, 9. 4, then 3, 6, 5, like this, then 5, then 4. Okay, in the decreasing order. Next, what is the next number? N into n minus 1, then n minus 2 in the decreasing order. If we go on in this way, then at the end we shall get 3 into 2 into 1. Correct. Now you see, my dear students, here, if we write this is n, then what it is? This is n minus 1 into n minus 2 into dot 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 into 3 into 2 into 1. Means this is also factorial n minus 1. In this manner, suppose here we want to write this part. This is 6 into this 6. What is this? This is factorial 5. Factorial 5. Okay. 5 factorial. What is the meaning of factorial 5? Factorial 5 means 5 into 4 into 3 into 2 into 1. This part. So this is factorial 5. So whenever a number is written, any factorial of a number is written, that number into the factorial of its next or the consecutive next number. Okay, in the decreasing order we are saying. In this way, what we can express this? Factorial 10 means 10 into this. What it is? This is factorial 9. 10 into factorial 9. So similarly, can you say this is the last example we are taking? Then we shall start this first question. If factorial 8 is written, how can we express in this manner? 8 into factorial, what is the number? 7, right? Okay, one more example. Suppose factorial 12, how will write? 12 into factorial 11. Okay, in this order we can express this. Now let us start question number 1. Before starting, let us rub all this part. Now dear students, let us start question number 1. Let us read the question. Find the value of, we have got 6 bits here. Let us take the first one. What is the solution of first one? Factorial 5. Factorial 5 means 5 into 4 into 3 into 2 into 1. What is the value of it? Let us just multiply. We have to multiply here. 5 4 is 20. Okay. 3 2 is 6. 6 into 20, 120. In this way we can finish. We can do this sum. You see, the sum is very, very simple. Now in the second one, what it is? Factorial 4 plus factorial 5. Factorial 4. Okay, let us try to apply the identity or the formula what we have done just now. Factorial 5 means 5 into factorial 4. So what is common here? Factorial 4 is common. So what is left? If factorial 4 is common here, what will be left here? 1. And here if this is common, what will be left here? 5. So this is factorial 4 into 6. Factorial 4 into 6. Now what is factorial 4? 4 into 3 into 2 into 1 into 6. So this 6 into 6, 36. 36 into 4. Let us do 36 into 4. 144. Got it? 144. 1, 2 done. Now number 3. Solution of number 3. Factorial 9 divided by factorial 7. Now factorial 9, how can you express? 9 into 8, then remaining part we can write as factorial 7. Got it? This is factorial 7. This factorial 7 we get cancelled. This is, what is their product? 72. Okay, then 3 is done. Now let us do number 4 here. Number 4, what it is? Factorial 6 minus factorial 3. Factorial 6. So this can be expressed as 6 into 5 into 4 into factorial 3 minus factorial 3. From these two, what is common? Factorial 3 is common. Let us take common. So what will be left here? 6 into 5 into 4. Okay, this is taken common, minus 1. This is factorial 3. What is their product? 120 minus 1. So this is 3 into 2 into 1. This is 119. So let us multiply 119 and 6. 714. Okay, now up to 4 we have done. Now these two are left. Now dear friends, let us do number 5. This is very simple sum. So this is factorial 12 factorial 2 into factorial 10. Now this factorial 12 can be written as 12 into 11 into the next, all the number, those can be expressed as factorial 10. Now this is factorial 2 into factorial 10. This factorial 10 we can get cancelled. Now let us express this factorial 2 in this way. 2 into 1 we can cancel. So what is their product? 6 into 11, 66. You see, very easy sum. Now this is quite multiplication is there. Number 6, root 3 into root 7 we have to multiply. Okay, so this is 3 into 2. There is no other way. We have to multiply all the number. This is 7 into 6 into 5 into 4 into 3 into 2 into 1 in this way. So 3 to just 6 and 6, 36. Okay, their product is 36. Okay, I am writing this 6, 36. Then this is 42 and this is 20. Okay, so 36. Then what is their product? 42 into 2, 84. Okay, now let us multiply these two. 84 into 36. 3024 and this 0. In this way we have solved question number 1. Okay, now my beloved students, we have taken question number 2. Question is, show that factorial twice n equal to this. Now how can we express? Here let us take the left hand side. Factorial twice n. Now according to suppose this n, factorial n means n into n minus 1 into n minus 2 into dot 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 into 3 into 2 into 1. In this way we express. So here this can be expressed as twice n. What is the next immediate number? Twice n. In the decreasing order always we shall write. In this way always we will write factorial twice n minus 1. Next is twice n minus 2. Next is twice n minus 3. Next is twice n minus 4. In this way if we go on, what will write? 5 into 4 into 3 into 2 into 1, isn't it? Now what we do, we make two groups. One is for the even number groups and another for odd number group. Let us do that. This is twice n. Next is twice n minus 2. Next is twice n minus 4 into dot 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 into that 4 into 2. This is one group. Alright, let us write like this. In another group, the odd number group, that is twice n minus 1. Next is twice n minus 3 dot 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 into this 5 into 3 into 1. 5 into 3 into 1. In this way you express. Okay, now here what do we observe? From here you see this 2 and 2 is common. This is okay, this let it be 2 and here 2 is common. So what will write? This is, if 2 is common, this is n minus 1. 2 is taken common. Here 2 is taken common. This 2. What will be left? From here n will be left and from here this 2 will be left because 2 2 is 4. Okay, dot 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 dot. Then let it be like this. Okay, this 4 can be written as 2 into 2, then 2, this 2 can be written as 2 into 1, and this is same thing we shall write twice n minus 1 twice n minus 3 dot 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 5 into 3 into 1. Correct? Okay. Now here in each term 2 is there. Each term is a multiple of 2. So if we take 2 common, this 2 into 2 into 2 into 2, this 2 into 2. So how many 2 are there? There are n number of 2. From here we can understand there are n number of 2. So what is their product? Suppose this is 2 into 2 into 2. If there are 3 2, this is 2 cube. 2 into 2 into 2 into 2. What is their product? 2 to the power 4. In this way, if there are n number of 2, what is their product? 2 to the power n. Their product of these two. So what will be left? N, here n minus 1, here n minus 2, dot dot dot. This 2 is taken common, this 2 will be left. This 2 is taken common, this 2 will be left. Okay, then this one let us write here. Okay, this is twice n minus 1 twice n minus 3 dot 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 into we can write 5 into 3 into 1. Got it? Okay. Now this is 2 to the power n into what it is, my dear students. This is nothing but this factorial n. You can check. This is factorial n into n minus 1 into n minus 2 dot 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 3 into 2 into 1 is factorial n. So this is factorial n. Sorry, factorial n we shall write like this only, factorial n, and into this product of this also. Now this can be according to the demand of the question, we can write like this. This is written in this order, in the reverse order. So let us write 1 into 3 into 5, 1 into 3 into 5 dot 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 into this twice n minus 3 into twice n minus 1. Now according to the demand of the question, let us express everything. At first 2 to the power n into this factorial n, then this. How we write? 1 into 3 into 5 dot 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 into what it is? Twice n minus 1. In this way we have expressed. This is the right hand side. Have you understood? My beloved students, we have taken question number 3. Let us read the question. How many words the words may have or may not have meaning can be formed with the letters of the word English, ENGLISH, taking 3 at a time? At first we have to understand what is the meaning of this. Here, okay, before understanding this, how many alphabets or letters are there? There are, if we count, there are 1, 2, 3, 4, 5, 6, 7. 7 letters in the word English. Now question is, we have to select, we should not select, we have to take 3 letters, either this or this or this, or in other way also you can suppose this or this. In any order we have to write, we have to take 3 alphabets, 3 at a time. At a time we shall take 3 alphabets. Any 3 alphabets you can consider. It is not necessary that you will consider only G initially or E initially or E and G. You have to consider 3 alphabets, any alphabets. Okay, suppose this is the first alphabet, this is the second alphabet, this is the third alphabet. Okay, now this first alphabet can be, this place can be filled in how many ways? As there are 7 letters, so this first alphabet can be filled in 7 number of ways. Correct? So let us write this. The first place can be filled by 7 ways. Now one letter we have already filled up this. Now suppose this place we have to fill up. Okay, one already we have taken, already we have filled up. Second place can be filled by how many ways? Now you see there are now how many letters or alphabets remained. Let us count 1, 2, 3, 4, 5, 6. There are 6 ways. Okay, so suppose this place is also filled up. Now we have to fill up this. That is third place. Third place can be filled by how many ways? Now how many letters are there? Let us count. 1, 2, 3, 4, 5. So that 5 ways. Got it? Now we have to find the total number of ways. This is the question. How many words? So total how many words can be found here, with meaning or without meaning? This is not mentioned here, but question is only we have to find the words. The words may have some definite meaning or may not have definite meaning. Now therefore total number of ways, what will do? We shall simply multiply 7 into 6 into 5. So 7 6 are 42, 42 into 5. Okay, let us multiply 42 into 5, 210. So in 210 ways this can be done. Alright, we have taken question number 4. Let us read the question. If repetition is allowed, how many even numbers of 2 digits can be formed with the digits 1, 2, 3, 4, 5? Now you have to careful here. The number which will obtain, that is even number of 2 digits, that is in that number there is only ones place and the tens place. Okay, suppose one example I can show. Okay, apart from this, one example is suppose 86. This is an even number. Okay, how can we find that this is even number? At first, even number cannot be found with this digit. Even number can be found with the digit in the ones place. Okay, in the ones place, if it is even number, the number may be if the number is even number, the digit in ones place may be 0, 2, 4, 6, 8 in this way. So here these are the digits given. Now at first we cannot start with this. We have to at first fill up with ones place. Okay, ones place can be filled up by how many ways? In ones place can be filled up by how many ways? That is the main question here. Now which are the even number digits here? This is one even number digit, this is another even number digit. So the ones place can be filled up in 2 ways. Okay, now here question is repetition is allowed. That means in the tens place again you can take these 2 digits. Again you can take, because it is said repetition is allowed. It is not that you have taken these 2 in the tens place, this will not be allowed. This will be allowed because it is mentioned in the question. Now let us fill up the tens place. Tens place can be filled up by how many ways? Let's see. By all these digits, 10 place can be filled up. Only you have to be careful if 0 is given. If 0 is given, then the tens place cannot be filled up with the digit 0, because if you put 0, that will not, suppose it is 0, 06 is not a 2-digit number. This is 1-digit number. So if 0 is there, already it is not, since it is not given here, so easily we can do. But in some question 0 will be given. So in that question, those type of question, you have to be careful. Okay, so in those, whenever 0 is given, do not consider 0 in the tens place. Okay, this is my request to all of you. So here in this question, in this particular question, tens place can be filled up by how many ways? Let us take all this because repetition is allowed. So how many digits are there? 1, 2, 3, 4, 5. So 5 ways. Now question is, therefore, question is how many even number of 2 digits can be formed? Therefore, number of even number of 2 digits can be formed will be equal to how many numbers? We shall multiply these 2 into 5, 10. So there are 10 numbers we can obtain this, that is even number of 2 digits. 10 such even numbers we can obtain with these digits. All right, let us read question number 5 now. Without repetition, okay, the condition is that we cannot repeat. How many numbers of 5 digits? There are 5 digits. 1 2 3 4 5. 5 digit number can be formed with the digits. Digits are given from 0 to 9. Now at first always we shall start with this here. Okay, this digit we shall start. Now can we, suppose we will obtain a 5 digit number. Can we start with 0? Never. Digit 0 can be anywhere except this. Even 0 can be here. Okay, suppose a number is there, suppose 2 3 4 5 1 2 3 4 0. That this is a 5 digit number. 1 2 3 4 5. This is a 5 digit number but end with 0. But let us take the in the reverse order. Let us start 0 like this. 0 5 4 3 2. Do you think this is a 5 digit number? No, this is not a 5 digit number. But this is a 4 digit number. So this place cannot be filled up with 0. So as we cannot fill up this place with the digit 0, we have to consider the other digits. How many other digits are there? There are 9 digits. 9 digits. Correct? Okay. Now this place is filled up. First place is filled up. Now suppose any digit you can imagine, any suppose 6. This is, suppose this digit is placed. Out of this one, this is placed. So the first place can be filled up with 9 number of ways. Now the second place, suppose one digit is selected here. Okay, it is taken here. This place is filled with any digit. Out of this 9, one digit is taken. Now what about the second place? When we consider the second place, say here 0 can be counted. So then how many ways that this can be filled up, the second place? Let us count. 1 2 3 4 5 6 7 8 9. This place also can be filled with 9 number of ways. Suppose any digit is selected, suppose 3. Suppose then the third place can be filled up with how many ways? Let us count. 1 2 3 4 5 6 7 8. 1 is taken, any this digit is taken. Okay, so this place is filled up. Now this place can be filled up in how many ways? Let us see. 1 2 3 4 5 6 7. So out of this, suppose 0 is put there. This is example. What we are cutting this means these are some examples. The last place or the ones place can be filled up with how many ways? Let us count how many digits remained. 1 2 3 4 5 6. So to get the total number of ways, what we have to do? We have to multiply all these numbers. Okay, so let us do. At first let us wrap this part. Now let us start solving. First place can be filled up in with how many ways? With 9 ways. Second place can be filled up with how many ways? 9 number of ways. Third place can be filled up with how many ways? 8 ways. Explanation is already done. Then fourth place can be filled up with 7 number of ways. Then the fifth place, this is the last, fifth place can be filled up with 6 ways. Now let us find the total number of ways. Therefore total number of ways. What we'll do? We have to just multiply 9 into 9 into 8 into 7 into 6. Okay, let us multiply. 9 9 is 81. 81 into 8. 81 into 8. 648. 648. Okay, these three are taken. And this is 42. Let us multiply these two. This is 27216. That is 27,216 ways are there. Alright. We have taken question number 6. Let us read it. Without repetition, you see, condition is that repetition is not allowed here. How many 4-digit numbers? 4 digit 1, 2, 3, 4 can be formed with the digits 1, 3, 5, 7, 9. Okay. So here there is no 0, so the sum is very easy. If there is 0, then we have to be a little bit careful. Okay. Now let us fill up the first place. This place can be filled up with how many ways? 1, 2, 3, 4, 5. In 5 ways. Suppose this is selected. This is chosen. Then the second place can be filled up with how many ways? 1, 2, 3, 4. 4 ways. Suppose this is done. Third place can be filled up with how many ways? 1, 2, 3. 3 ways. Suppose this is selected. This is done. Then the fourth place can be filled up with how many ways? 1, 2. 2 ways. Okay, this is done. Now, question is, without repetition, how many 4-digit numbers can be formed? So, what will be the total number of ways so that we can choose a 4-digit number from these given digits? What we'll do? We shall just multiply 5 into 4 into 3 into 2. But before that, we have to write everything. First place can be filled up with how many ways? 5 ways. Second place can be filled up with how many ways? 4 ways. Third place can be filled up with 3 ways. These three ways. And about the last one, this one. Fourth place can be filled up with how many ways? 2 ways. Okay, so therefore total number of ways, what will do? We shall multiply. Let us multiply 5 into 4 into 3 into 2. 5 into 4 into 3 into 2. Okay, you see 5 2 is 10, 4 3 is 12, 120 ways are there. Alright, my beloved students, we have taken the last question of this exercise 6.1. Let us read the question. How many ways the letters of the word number can be arranged? Okay, how many places are there? 1, 2, 3, 4, 5, 6. Okay, so there are 6 places. 1, 2, 3, 4, 5, 6. Now here, first of all, one thing is not given, that repetition is not allowed here. This place can be filled up in how many ways? 1, 2, 3, 4, 5, 6. 6 places. This number, so one alphabet or one letter is already chosen. Okay. Then next place can be filled with 5. We have already understood in last few sums. This third place can be chosen by 4 ways. This one by 3 ways. This is 3 ways, this is 2 ways, this is 1 ways. So here first question is how many ways? So let us find the total number of ways. Total number of ways. What we'll do? We shall simply multiply 6 into 5 into 4 into 3 into 2 into 1. Let us multiply. 6 is 36. 36 into 20, 720. Because 36 into 2 is 72, so 0. Then in number 1. Now the condition is given. What is the condition? How many of these will start with the alphabet M? That is, how many alphabets are there or letters are there. 1 2 3 4 5 6. Here also 1 2 3 4 5 6. Condition is that first place always will start with M. This is fixed. This is given. This is M. This is fixed. So if this is fixed, what can we do? We cannot do here. We cannot put any other alphabet here, but we can put alphabets here. This, see here in the number, the word is number, NUMBER. This is already selected, already chosen. So the next place can be filled up with how many ways? 1 2 3 4 5 ways. Okay, this place, suppose this is chosen, this place can be filled up with how many ways? 1 2 3 4 ways. Suppose this is chosen, then this place can be filled up with this 3 ways, this is with 2 ways, so this is taken, and this is 1 ways. Got it? So let us write the total number of ways. Total number of ways in the given case, we shall multiply 5 into 4 into 3 into 2 into 1. Okay, this is 3 to just 6 and 20, 120. Got it? Then number 2. Here, how many of these do not end with B? 1 2 3 4 5 6. Here there may be any alphabet in the last place. Here condition is that how many of these do not end with B, that is the ending alphabet cannot be B, any other except B. Okay, so B can be anywhere but not here. So this, again let me write 1 NUMBER. Okay, so in this place all the alphabets can be there except B. So this place can be filled up with how many ways? 1 2 3 4 5 ways except B. B cannot be there. So remaining number of alphabets, again let me count, 1 2 3 4 5. Okay, then 1 is chosen. Suppose this is chosen, correct? Now here this place can be filled up with how many ways? Let us count. 1 2 3 4 5 ways. Okay, because now B can be chosen here. B could not be chosen there. Okay, but B can be chosen here. One alphabet is chosen here for this place. Now this place can be filled with how many ways? 1 2 3 4 ways. This is done. This place can be filled with 3 ways. This is done. This is with 2 ways. This is done. This is with 1 ways. Got it? So here let us write. So what the basic thing we have obtained, that if the thing is given, condition is given, cannot end with B, always we have to start with the end only. Okay, that is this place. Otherwise always all the sums we do start from this side, but in this particular sum we have to start from this side. Keep it in mind. Okay, so here total number of ways. Total number of ways. Let us multiply these two. Let us multiply in this order. 5 into 5 into 4 into 3 into 2 into 1. 5 4 is 25 into 400, 3 2 is 6. 600. Is it okay?